Bismillahirrahmanirrahim. Assalamualaikum and very good morning to everyone. My name is Hazi Mokles. I will chair this keynote speaker by Dr. Zahrul Faizi. I would like to welcome everyone to the 2022 IEEE International Conference in Power Engineering Application, ICPEA, which is conducted in hybrid mode and also in physical mode, both online and also physical, face-to-face. Today, it is a great honor for me to chair this session. Today, we have the keynote speaker, Dr. Zahrul Faizi, that will deliver his keynote entitled Renewable Energy Development in Malaysia and its Challenges. Before I hand over the floor to Dr. Zahrul Faizi, let me introduce IR Dr. Zahrul Faizi. IR Dr. Zahrul Faizi is presently the Chief Executive Officer of the Power Division Runhill Utilities Berhad. Prior to his current position, he was the head of company Malakoff Utilities in Berhad from 2013 to 2016, a wholly owned subsidiary of Malakoff Corporation Berhad that operates electricity distribution network and district cooling chill water supply. He served as General Manager, Transmission and Distribution at TNB Research from 2009 to undertake research, technology development, and technical services that contribute towards improving operational and technical performance of TNB. In 2000, he joined University Tenaga Nasional as academic faculty member. During this time, he also served as a senior consultant at the University Power Engineering Center and lead the Department of Electrical Power Engineering as its founding head of department. He was promoted to an associate professor and received a number of accolades, including the Anugerah Harapan Tokoh Pekerja Lelaki by the Ministry of Human Resource in 2007. He began his career as electrical engineering with Tenaga Nasional Berhad in 1995. Between 1996 and 2000, he undertook a PhD program in electrical power engineering at the University of Southampton, UK. During this time, he worked on collaboration project with Southern Electric and International Energy System, a subsidiary of British Nuclear Fuel Limited, to develop a novel energy storage system based on high-speed centrifuge technology. He also gained his early teaching experience by tutoring undergraduate students at the university. IR Dr. Zahrul Faizi also active in IEEE PES as a senior member of the Institute of Electronic Engineering. He served as the chair 2008, 2010 and vice chair 2006, 2007 of PES Malaysia chapter. He was appointed as chapter representative Region 10, PES IEEE from 2011 to 2014. He is also a registered professional engineer with the Board of Engineers Malaysia and corporate member of the Institute of Engineers Malaysia. So we can see that Dr. Zahrul Faizi has a vast experience not only in academic but now in a practical side. Therefore, I would like to invite Dr. Zahrul Faizi to deliver his keynote entitled Renewable Energy Development in Malaysia and its Challenge. Dr. Zahrul Faizi, the floor is yours.
Thank you very much, Professor Hazli, for the introduction. I would like to share with everyone present today my some knowledge and experience sharing on what we are doing at the moment at Renhill, and also personally what I think about what the industry is going through, especially at this moment on specifically on the development of renewable energy from a market or from a developer situated in Malaysia. But first, let me introduce to you the company that I'm now at. It is called Renhill Utilities Berhad. Renewable Utilities Berhad is an environment and power company. Um, it consists of two major divisions, power and environment. Power is where I am at. I'm leading the power division of Renewable Utilities. We have at the moment two 190 megawatt combined cycle gas turbine in Sabah on a build, operate and own and build, transfer and own basis. So it makes us a total of 380 megawatt capacity, which is the largest IPP in Sabah, which consists of about 37% of the combined installed capacity of power generation in Sabah. And that provides electricity to about 1.4 million people. And the turnover in the power division is about between 300 to 400 million a year. We believe that combined cycle gas turbine, which uses natural gas to produce the power that we then sell to the off-taker, is clean energy, but we would like to go into a cleaner environment. We would like to encourage um, the move away from fossil fuel based resources. So we are embarking on a renewable energy drive to grow our company revenue further from now until the next 20, 30 years. The other side of the company's business is in the environment sector. um, because Rand Hill is quite strong in the water business, water segment business. Um, we have uh, the total treatment capacity for water of about 1,986 million liters per day in our source to tap services in Johor. Rand Hill holds 80%, about 80% of the as a shareholder in Syarikat Air Johor. At the moment, it has the lowest non-revenue water per kilometer of pipeline in Malaysia, and the turnover from the environment sector is about 1.1 billion per year, and it provides water to 3.7 million people in Johor, in the state of Johor. Other than the main two businesses, environment and power, namely water in Johor and power in Sabah, Renil also owns concession businesses in China, mainly concession agreement with local authority or industrial park management council. What we do in China is we own wastewater reclamation and potable water treatment plants. And the total treatment design capacity in China is about 340 million liter per day. Renil also owns water concession in Thailand, especially at the industrial park, with the concession agreement with the park developers and other private enterprises. We have 8 water and wastewater treatment plant and 1 reclamation plant with a total design capacity of 102 million liter per day. Now let us go into the renewable energy development in Malaysia and how I'm going to summarize it uh, to the most recent development drive of renewable energy in Malaysia. Uh, last in the last 2 years, the Ministry of Energy and Natural Resources of Malaysia have set a target of 31% renewable energy share in the national installed capacity mix by 2025. That is a very, very high or very ambitious target that the, the ministry and the government has set as a national agenda. And a blueprint or a roadmap called Malaysia Renewable Energy Roadmap has been commissioned to support further decarbonization of our electricity sector, moving away from fossil fuel based energy generation technology. So it is expected to drive the reduction in the power sector greenhouse gas emission, which is to support the Malaysia global climate commitment. Now, the bigger and the further target for the Malaysia Renewable Energy Roadmap is to reduce Malaysia economy-wide carbon intensity against our GDP of 45% in 2030. And now we are already in the year 2022. Uh, it's not too long for us to go. And this economy-wide carbon intensity reduction of 45% is compared to the 2005 level, and then a further reduction to 60% in 2035. Now, the roadmap, MyRER, considers two distinct scenarios for RE development. It um, simulates the two different scenarios in our country towards the committed RE target for 2025 and then through to 2035 milestones. Basically, we looked at two scenarios. Number one is business as usual. If you look at the graph that is shown on the screen now, the business as usual is the one with the blue line, and then new capacity target. The new capacity target is the one with the green line. Now, what is business as usual? Business as usual means by implementing the existing policies and programs only without further extension or without any introduction of new programs. So if we look at the business as usual scenario, you can see that the baseline at 2020, which is the same as um, it started at the same baseline at 2020. We have about 8,450 megawatt, yeah, which is about 23% RE share. But also when we say 8,450 megawatt capacity, we have to remember that some of the renewable energy sources are intermittent. That means it's not 24 hours. And it's not dispatchable. For example, for solar, if we say we have solar capacity of 100 megawatt, doesn't mean that we can generate 100 megawatt 24 hours, 7 days a week. So we have to look at the megawatt capacity of RE in a slightly different light compared to the conventional thermal generation. Now, at business as usual scenario, when we look at the year 2025, the target would be 11,742 megawatt, which is 29% of the RE share. And when we look at 2035, which is the target end of the milestone that is being set in the roadmap, it is 13,746 megawatt, and which is a 32% RE shares. Now, the roadmap also look at the new capacity target, which aims for higher RE capacity target to align with further decarbonization of the electricity sector in Malaysia, which is towards the 2035 milestone. So now this is the additional capacity target that the government has introduced and going to implement to further decarbonize the electricity sector in Malaysia and move towards further away from the fossil fuel resources that we are now mainly using. So if we look at the 2025 target, the new capacity target would be 12,916 megawatt, which is 21% RE share, 2% higher than the business as usual. And the new target, capacity target at 2035 has now become 40% RE share, which is 8% higher than the business as usual. So this is, in a nutshell, this is what the government is trying to push us to go into renewable energy, and we did all the incentives and motivation that would be provided by the government for RE development in Malaysia. Now, if we look at the resources for RE that's available in Malaysia, my RER formulates also the strategy in maintaining affordability and system stability. That means when we talk about affordability, we need to look into the price of the renewable energy resources, the technology, and also the feasibility, the financial feasibility of getting this energy into the generation capacity for the country. And when we talk about system stability, we look at how the characteristics of the renewable energy interfere with the stable grid operation of tenaga. So if we have intermittent resource, for example, solar, that is very dependable upon the weather, whether it is windy day, whether it is going to be a rainy day, or whether we have a lot of cloud cover. So we look at the percentage of um, solar power capacity within the whole system and how much penetration we can allow the intermittent solar to be in the grid. The roadmap also optimizes the socio-economic benefits from the development of RE in Malaysia. So, for example, if we look at the resources of the or the characteristics or how the RE development is going to be implemented in Malaysia, the blueprint also look at how the technology and how the implementation of the RE technology can benefit the socio-economic status of the people in Malaysia. So, for example, if we look at hydro, if we develop hydro would require a very high upfront cost for the infrastructure, number one. And number two, it may not give the best or the highest job opportunity available for the masses. Whereas if we look at bioenergy, for example, where we have collaboration and cooperation with small farms that generates the downstream economy through oil palm plantation, for example, and then it uses the EFB or empty fruit bunch from the oil palm plantation. So it generates more downstream economy for the masses. Also, the roadmap look into how the global climate change agenda is being tackled in implementing the RE in decarbonizing the power sector. And throughout all this, the blueprint requires high commitment by policymakers, industry players, and strategic partners, including financial institutions. Now, a snapshot at the resources, the renewable energy resources in Malaysia. If we look at solar PV, it has the highest potential of renewable power in Malaysia, um, estimated about 269 gigawatt. And from the bubbles, you can see those are the areas that is very high in terms of solar intensity that would provide the highest solar PV resources. Large hydro is estimated at about 13.6 gigawatt. Bioenergy is estimated at about 3.6 gigawatt, and small hydro, many small hydro, 2.5 gigawatt. And we also have small capacity for geothermal, 0.2 gigawatt. And you can see that geothermal energy mainly is within the east coast of Malaysia, Sabah, and some area in Semenanjung. Now, I'm going to emphasize and focus my presentation today and a sharing session today on the solar PV power generation, because as we can see from my previous slide, the largest RE resources in Malaysia that we have at the moment is from solar. And we can see there are a lot of solar, large-scale solar implementation is being encouraged and being spearheaded by the government through this initiative to develop RE for many years already. So just for completeness, I will go through the solar PV power technology. I'm sure every one of you are well versed on how solar is being used to generate power. The solar electric panels create the electricity directly from sunlight. When the sunlight hits the panel, the semiconductors inside the solar panels are activated and DC is produced. And this DC power is collected through the PV arrays and the distribution board. And then inverters converts the electricity from DC to AC. And AC power voltage is then raised via the distribution transformer, and subsequently is stepped up to the grid, to the relevant grid voltage level. Either is at 11 kV in Malaysia, 33 kV, or 132 kV, depending on how much power that is being collected from the solar plant. Now, some recent development on solar power in Malaysia. On 14 February 2019, Suruhanjaya Tenaga floated the third tender for large-scale solar LSS3 with a total capacity of 500 megawatt for Peninsular Malaysia, where a total of 107 bid submissions were received by Suruhanjaya Tenaga. And if we were to total up all the 107 bid submissions, it totaled for 6,731 megawatt solar capacity received. So it begs the question, it begs me to ask this question also. Now, if we have 107 parties ready to implement 6,731 megawatt solar, why can't we award the solar concession to everyone, right? So that we can speed up the implementation of developing solar development, solar capacity development is in Malaysia. But the answer is not that simple. So although if I were to think from only from an engineer technical perspective, I would say, why don't we do it now? But of course, in the blueprint, there are stages that we have to go through, and because there are different challenges in terms of developing a certain capacity. So we will talk about the challenges in implementation later on. But anyway, the LSS3 tender exercise was only for a total capacity of 500 megawatt. And then more recently, on the 31st May 2020, another exercise, tender exercise was implemented, LSS4, large scale solar 4, where PV plants with a total capacity of 1000 megawatt for Peninsula was floated. So this is what when I say there are challenges to implementing uh, big large scale solar power plants like this, and it has to be done gradually so that when we do LSS3, there will be lessons learned from LSS3 that is then taken into LSS4 to make the whole process more efficient and better. The successful bidders required to enter into a solar power purchase agreement with Tenaga Nasional Berhad for a term of 21 years. Um, it's interesting to note, to share what the reference tariff was set by Suruhanjaya Tenaga. For LSS3, it was at 32.4 cent per kilowatt hour, while for LSS4, it was at 24 cent per kilowatt hour. So if you recall, the time difference between LSS3 and LS4 was not that long, but you can see the price, the reference tariff that was set by Suruhanjaya Tenaga changed quite a lot from LSS3, which was at 32.4 cent, and then LSS4 at 24 cent. So you can see, we can see that the price for solar is going down from LSS3 time into to LSS4 time. But we will come back to the question of solar pricing again. So now, from the point of view of market player or RE developer, there are, I would say, four main competitive factors that are in play when we talk about developing large-scale solar power plant. Number one, what is important is the land cost, the low lease and development cost for the land. That means number one, um, it's beneficial if the land is not priced high. So that means we have to find a land that is quite far away from city center, because of course the land nearer to the city center costs more, and also because it involves a lot of land. Then we also need to look at the lie of the land. And then we also look at the low interconnection facilities cost. By that, we mean that it is a paradox in some way, because we want to find land with low cost, so we have to go further far from a developed area. But at the same time, we want to be near where the load is, because we want to have low interconnection facilities. So low interconnection facilities cost means we need to site our um, solar plant nearest to a main substation so that we can inject into the main substation. Um, the interconnection facilities, cables, or overhead transmission line cost a lot. So as far as possible, we want the substation to be nearest to us. And we know main substations are mainly built near the load, where the loads are, which is near the cities. So it's quite a different a sweet spot that we are trying to find. And number three, low financing costs. Because we need to be competitive, we need to find the lowest possible financing cost in terms of interest rates, and also from the point of view of the market player or the investor, we need to be reasonable on the expected rate of return that we would expect from this kind of investment in a solar power plant. And lastly, we need to find a very good EPC. Um, EPC with good technology, good experience that will also give us a lower cost. So with all four of these criteria, then it would be competitive for a market player to go into the bidding um, exercise. Now, from an energy company point of view, why is solar investment attractive? Number one, solar market is considered mature. If you compare to all other renewable energy technology, for example, solar is one of the simplest power generation method. Easy installation, low maintenance, no rotating components in the generator. And it is because of the mature solar market and because of the simple technology that we are dealing with for PV solar power plant, it is a good entry and good exposure for RE market player to go into, to start exposure to the renewable energy. And then when we talk about the PPA, the solar power purchase agreement, we are looking at also the possibilities to be able to sell after the SPPA ends. After 21 years, when the SPPA ends, um, if we were to develop a large-scale power plant that has more life than that, more than 21 years, then there is a possibility that we can sell that is going to be already being implemented, is being planned, is being implemented, and of course, after 20 years, the country will move into the electricity market structure. So there will be PPA, and of course, solar being a green technology, green business, there are a number of carbon credit and green incentive being prepared and being offered for solar. And I would say because of the simple technology, the risk low with short construction period. And if we choose the land carefully, the suitable land that we have for the solar power plant, there will be minimum civil works involved. Now, what are the typical solar project risk profile? This is an example. It may not be the same for all solar power projects, but this is an example or a typical solar project risk profile that I can share with everyone. List of list of key risks that we are seeing. Number one, we need to be able to make sure that our project will be carried through into proper completion and good performance by the EPC. So, number one, the financial strength of the manufacturer and the EPC has to be ensured. Capability to fulfill the guarantees that we put in the contract for the EPC. We have to select the most reputable EPC, but at the same that offers competitive pricing. And number two, we have to have um, enough equity requirement that we can then put into the business, into the project. Uh, and typically, the equity requirement is about between 15 to 20% of the total project cost. And number three, delay in obtaining development order. This is very important because when we tender for projects like this, there will be a set amount of time for us to construct and then commission the project. So any delay that is being put into the project is very, very important. So one of the things that we can see here in Malaysia, in the situation in Malaysia, is that there may be some hiccup or there may be some delay in obtaining development order. Why? Because development order also depends on the the land matter, also on the requirements that we have to fulfill and so on. So I will talk a little bit more about the development order or the risk that I am going to pick from all this list. And then we are going to discuss in detail. Number four, type of loans, uh, reputation, and the experience of the EPC, and also the number five, not so much of a concern, but we have to look at the performance of the solar plant equipment and system when we choose the panels, especially the panels and also the solar plant. And number six, panel price increase. This wasn't a big concern until a couple of years ago when I'm going to show you how it has now become a very, very important um, issue that has uh, challenged the solar power developers in Malaysia. So panel price increase is very important, and coupled with inadequate performance and warranty bonds coverage by EPC, it can become a very significant risk for the developer. Now let's talk about the risk of delay in project execution due to land matters. Now this may seem to be quite simple or easy to solve, but unfortunately it's not. It's not something technical. It's not an engineering problem, but it's more to do with process and how so for us to be able to develop the solar power plant because the land required is huge. For every 1 megawatt of capacity, we need about 3 acres of land. So for a 50, 100, one take panels on, maybe we need to um, um, set aside some area for us to have a retention pond and so on. So it can go up to 170, 180 acres for a 50 megawatt solar power plant. So most of the time, it's very difficult for us to get is already
So I believe there is a technical issues. Maybe we can wait for a while so Dr. Zahrul Faizi can continue the presentation.
Dr. Zahrul, can you please share your slide again?
okay. I will share my slide. Okay. Um, can you see the slide now?
Not yet, Doctor. Not yet.
You can see is the slide okay now?
Not yet. The slide not appear yet, Dr. Zahrul.
Okay. Let me try again. Can you see the slide now?
Yeah, yeah. You can see the slide.
Okay. So let me continue. Sorry. Uh, so now we talk about the typical solar project risk profile. So basically, we have the financial strength of the manufacturer, the EPC, equity requirement, delay in obtaining development order. I will talk a little bit more about the delay in obtaining a development order, completion delay due to construction risk, low performance of solar plant equipment, and the panel price increase. I will pick a few of these key risks to then talk a little bit more about. Um, Now, this is one of the most important thing that will ensure whether the project, the solar project, can be implemented and uh, completed on time or not. Um, One of the things that is very important is the land zoning. Now, in Malaysia, we have the local authority and the state planning agency that has already decided many years ago which which land can do what. So some land are being zoned into industrial land, some are agriculture, and some are for residential. So um, if usually when we talk about the solar power plant needs to use a lot of land. 1 megawatt requires about 3 acres of land, so 50 megawatt will require about 150 acres, between 150 to 180 acres, depending on the lie of the land and so on. So most of the um, land that is being identified to be used for solar power plant usually comes from agricultural land, because agricultural land is one cheap, and also number two, it's far away from the city center, and therefore the cost is low. So if the land is being zoned into the agriculture area, then we have to convert it, because the solar power plant is considered industry. So typically for land zoning process, it takes a lot of time, typically about 8 to 12 months. And then we also have the development order, a prerequisite to the commencement of physical work at the site when we already have done uh, ESIA and so on. And typically the process owner is the local authority, and it takes about 3 months. And when we have this change of land and express condition, we also have to subdivide the land title for us to use it for only for the solar. If we are taking only 150 acres from a land title of, let's say, 400 acres, then we have to subdivide the land so that we can then do the contracting and agreements and so on, land lease agreements and contracting and so on. And typically this will take 6 to 12 months. So as you can see, the lead time is long, and therefore the land zoning application process must commence even before the award of the project. We talked about the solar panel price risk just now. So this is very important at the moment, because now that we went into pandemic about 2 years ago, and we have seen previously we have seen that the solar panel price goes down and down and down, and typically that is for the past 10 years that was what happened for solar. But suddenly when the pandemic came, we saw that the solar price panel increased sharply. Okay, we need to understand why. If you look at the graph that I'm showing at the moment, you can see that the commodity price relative to January 2020, the price of polysilicon goes high towards the end of 2021. So what happened was that we have all around the world we have material shortage. Solar panels are made from polysilicon, which is sliced into razor-thin wafers and wired into cells, and increase in demand overwhelmed the existing manufacturing capacity all around the world for polysilicon. Polysilicon is I would say, the most basic building block of a PV cell. So the PV market bounced back from COVID-19 pandemic more quickly than we expected. So several new players entered the solar wafer market in 2020 and 2021, and it spurred the demand for polysilicon, and it triggered a price rally in February 2021. So in late 2021, polysilicon was trading at a 10 years high. So you can imagine for those um, market players that has already bid and won the large scale solar project award back in 2021, and now only going to be implementing uh, the construction and building of the power plant. Suddenly the price goes up, and this is quite unprecedented, because we have never had a, a pandemic as big as COVID-19 before. Also, other raw materials have climbed steadily as pressure to module production increases. You can see silver, copper, and aluminum also rise steadily, not as high and as abrupt as polysilicon, but nevertheless, silver, copper, and aluminum also rises. And then we also have freight cost problem, freight cost increase. Freight cost means the shortage of shipping containers. Freight costs soared due to lack of shortage of shipping containers. So during the pandemic, containers are used for more than shipping. They are transformed into many parts, into makeshift schools, restaurants, hospitals, clinics, and so on. But during the pandemic, high demand in transportation of goods leads to shortage of containers. So port congestions and closures are part of the problem, which is caused by COVID-19 outbreak, and it sent the freight cost surging. So you can see year-on-year growth. Towards the end of 2021, you can see all the rate index gone up. So the shipping containers during this pandemic can't be unloaded at the dock fast enough to be sent back to the original location. So where they will be used again to put goods in, and then to ship goods in. So container delay is a contributor to the global supply chain problem. Now, other factors why the solar panel price increased due to some core component price inflation. So manufacturing costs for PV modules surged from below 20 US cent per watt peak in 2020 to 26 to 28 US cent per watt peak in the second half of 2021, which is near 50% increase in a year. Also, it was due to China's decision to relax energy consumption rules for renewable power-related materials. So recently announced project promised to use wind and power to power their polysilicon production lines. So because China wants to reduce the emission level very, very drastically, so they are scrutinizing the power generators. So more power generators are going to or promise to use solar power, and therefore it has increased renewable energy or solar power demand during this time. Now, let's look at the solar panel increase outlook. So now, what happened next? So good news. We can see there are new factories being built around the world. Global polysilicon producers have increased their capacity. For example, in China, Tongwei, Daco, and GCL Poly Energy has opened new lines with combined capacity of 160,000 tons a year. Now, this increases the global capacity to 620,000 tons per year by 2021. So we can see now the price has came off 17% since November 2021. and another 550,000 tons per year of capacity is under construction by end of 2022. So we can see that with new factories, there will be increase of material supplies. So new plants takes about 18 to 24 months. So we are looking at, or some analysts are predicting that the polysilicon prices will remain elevated in the first half of 2022, and then we are seeing that the polysilicon price will nosedive to a historic low in 2023. So we are still in 2022. It will remain elevated, will remain high, but we are predicting that the price of polysilicon will go down from 2023 onwards. So that would be when we would think the best time for market player and market solar power developer to go big into solar power development. Also, we are seeing that shipping containers capacity has increased back, and now we can see that COVID-19 pandemic has died down. Businesses have opened up. Therefore, ports and congestions and closure will ease and improve the efficiency of port operations. Now, just we have looked at the more or less the problems that is quite intrinsic to the solar power developer or solar power development. We talk about the EPC, we talk about land use, we talk about solar price increase and so on. Now, we also it's very important and very interesting to see the development in the world today. Geopolitical issues that comes and go, and in the last 2 weeks we saw Russia invasion of Ukraine that has shocked the world and triggered reactions such as economic sanctions. So when we talk about economic sanctions, we nevertheless we will have some kind of movement in the market, and that movement in the market will involve a lot of commodities, and I'm afraid solar panels now has become a commodity. So what does this kind of situation have effect on RE project development? Now we can see that the invasion of Ukraine has added risk to oil supply. With economic sanction growing, according to analysts, the longer the war goes on, the greater the chance of the price of oil to remain above the 100 mark. We had the price of oil reaching $130 mark recently. So with the oil costing more than $100 a barrel and the war in Ukraine underscoring the risk of relying on fossil fuel, so what does it tell us? Does it tell us that it is a good time to speed up the transition into renewable energy? Because now we can see that relying on oil is not a good idea, because now oil is going up, and now because of our economy relying so much on oil, energy relying on oil, then what happens to the economy, to the prices? What happens if suddenly the war situation comes down and the oil prices falls down again? So what happened to us, and how are we as the market or as the RE developer going to be affected? These are questions that doesn't have a clear answer. I'm putting it here for us to discuss and elaborate. But this is how I look at it. The public support for climate action is higher than ever in most countries, but that doesn't ease the economic pain, because everything from food to transport gets more costly. So an unfortunate downside of the economy that runs on fossil fuel, it makes imbalance between supply and demand a source of price volatility, including the current spike. Now, some analysts says that in 2020, some oil giants drastically pulled back on investments to increase production. on the assumption that COVID-19 lockdown would depress the demand for their product. But then when we look at how the pandemic developed, a quick rollout of the vaccines in the developed nation led to a faster than expected recovery. And now suddenly there is shortfall in supply of oil, and then the price slowly increased. And with the war situation in the Ukraine and Russia, then the price spikes. So does the elevated crude cost means transition to clean energy going forward easier? One argument, it says that the fossil fuel price will speed up renewable energy development. So this is what we are seeing. Typically, this is what we are seeing. Government policymakers put in policies to move away from the fossil fuel, and especially when a time when renewable energy, in our case, what we have been looking at, the solar energy has become affordable to customer. It has reached grid parity, and in some places it has become cheaper than conventional fossil fuel thermal energy. However, clean energy has merely only slowed down the growth of our fossil fuel demand, and it hasn't yet led to substantial decrease in oil consumption in most countries. Why? Because replacing fossil fuel consumes time, because infrastructure takes time. So as a conclusion, we can see that green energy source still only make up a small fraction of the world primary energy today. So if you look at the bar chart that I have on the screen now, you can see that the renewable energy is very small compared to the energy that we get from oil, coal, and natural gas at the moment. So we are just getting along. Renewable energy is not replacing the demand for fossil fuel, but rather merely slowing down the growth of the fossil fuel demand. But at the same time, when expensive oil or oil becomes expensive, inflation goes up. So when inflation goes up, it prompts central banks to raise interest rates. So as a solar developer, this also raised the cost of capital. So this also raised our competitiveness when we need to get financing for the loan to develop the renewable energy plant. So we have to also pay more to borrow and cover the high upfront cost of building solar power plants. So in a nutshell, as a summary, the picture is mixed. I've shown you what we have seen just now. Challenges in developing renewable energy, especially solar in Malaysia. We look at the short-term challenge, which was the polysilicon shortage solution, which is still ongoing, that we think will be resolved by end of 2022, going into 2023. And we are still positive, we are still optimistic that more and more capacity of renewable energy will be added to the capacity throughout the world. Bloomberg estimates about 455 gigawatts need to be added every year through until 2030 for the world to be on pace to avoid the worst effects of climate change. So hopefully, once the polysilicon bottleneck is removed by end of 2022, the prices will go down again, and then even more dynamic demand will be motivated. So we are hoping that the drive into renewable energy will be refreshed and will be more encouraged to flourish, and more capacity will be added to the world renewable energy capacity. But having said that, we have seen that some geopolitical situation around the world continue to be fluid. We have seen now a conflict zone has erupted in Ukraine and Russia, And we are looking at South China Sea region as another conflict zone that hopefully will not be dragged into similar situation that we have in Russia and Ukraine. So whether we like it or not, all these various development in the world affects the development of RE in one way or another. And as RE developer, from the point of view of RE developer, we need to keep abreast of the trends and the forecast. That's all from me. Thank you very much.
Thank you very much, Dr. Zahrul Faizi, for very informative presentation and sharing today. And I think we have learned a lot, especially from the perspective of industry related to solar panel, and we also learn about the challenges, and maybe some of the point that we never know is about the increment cost of solar panel due to various factors. So this is a very good presentation and very informative, and we learn a lot. So maybe now is the time for Q&A session. Dr. Ashida, where is the question? Okay. So this is the question. What are the challenges on implementing floating solar system in Malaysia?
Oh, thank you, Jordan. Floating solar system in Malaysia. The number one challenge in implementing floating solar is the cost. The cost of the structure, the floating structure, um, and also in terms of the maintenance of the floating solar system. We being a water company, we have a lot of reservoir in Johor, freshwater reservoir, where we take the drinking water and then treat the water and then pipe the water to the consumer. So the water treatment plant uses anywhere between 10 megawatt to 30 megawatt for the pumps and so on. So it is right, very suitable to implement floating solar system for our reservoir, because it is near the water treatment plant and it can be used directly in the water treatment plant that has big pumps and so on. But the challenge at the moment is really is the cost of a floating solar power plant. It is more expensive than a landed one because of the structure that we require. We also need to, well, technically it's not that a great challenge to design the how to tie and keep, because of the water level changing. We have to keep the floating solar intact and connected properly. So it's not a big challenge, but it is some technical challenge that needs design. But the main challenge at the moment is really the price, because when we want to propose a floating solar system for this water treatment plant, for example, we have to compete with the existing price that the water treatment plant is enjoying, the existing tariff that the water treatment plant is enjoying. So it is not, it is under industrial tariff. So industrial tariff is quite low. So the price hurdle for the floating solar is quite difficult for us to overcome. It can, given time, when the technology has matured and the price has goes down enough for it to be competitive, then it can. As compared to, let's say, if the floating solar is to be connected to an to a commercial entity, for example, then we are comparing different tariff. Industrial tariff is lower than the commercial tariff, so the hurdle will not be that high. So in a nutshell, we are waiting for the floating solar price or cost of project to go down until it can become technically feasible.
Okay, thank you, Dr. Zahrul. Um, okay, next question from Mr. Taufik. This is general question. Maybe how much solar power in Malaysia can everyone build at home? How about standard for install solar power for everyone in Malaysia, any off or on grid?
Okay, thank you, Taufik. Solar power in Malaysia is getting cheaper now, and at the moment, you can build your solar plant. You can build your solar panel and put it on the rooftop. I can imagine um, for a normal link house or maybe bungalow, you can have about up to between 3 to 5 kilowatt easily on the rooftop of the house. And for now, Malaysia has got a net energy metering scheme where when you produce power from your solar panel, even if you don't use it, especially if you don't use it in the during the day, when you are out and about and going to work, but your solar panel is producing, so your solar panel will then export to the grid, and then during the night when you use your lights and TV and cooker and so on, you take from tenaga that energy and it will be net metered for you. So you can consider tenaga grid as a big battery that you don't have to buy. So yes, everyone can build a solar panel on your rooftop at home.
Okay, thank you, Dr. Zarul. Next question from Ms. Harmini. I want to ask about technology. What is the technology or method in Malaysia to increase the performance of solar plant equipment and system? So, maybe in general, what is the technically how to improve the performance of solar plant?
Okay. For a large scale solar player, when we do the study and analyze the yield that we want to get from the given land area that we have, number one is the type of PV cell that we buy. Yeah, so the energy intensity or the yield of the solar panel per panel, 1 meter times 2 meter panel, either is 180 watt or 193 and so on. So of course, you are going to get more solar energy from unit area, but you pay more. Okay, so these are the things that we need to balance when we design the solar power plant. We want to optimize the land area and the yield that we get. So if you want to buy a cheaper, less expensive panel, then you have to use more land. And if your land is expensive, then you don't want to do that. So you buy high efficiency, high yield panel. That's number one. And number two, there are certain uh, motorized plane adjustments that you can do. But however, for us, for large scale solar, we want to have um, lowest maintenance. So we do not we are not encouraged to go into that kind of solution because it will involve motors, rotating elements that we have to maintain for 21 years and in a very big area, hundreds of acres. So that's not what we do. So we optimize in terms of the angle of the plane of the solar panel that we install on the land. Okay.
Okay, thank you. Next question. How to dispose a solar panel once they are useful life end?
Yeah, I have limited knowledge on how to dispose solar panels actually. So I know there are a number of companies. We don't do that business, but there are a number of companies that take in solar panels, and then they would recycle the materials from the panel. So we can separate between glass, and then we have the silicone, and also we have wires connections, metals from the solar panel. So it's not within our business, and I have limited knowledge on that.
Mm. Okay, thank you. I mean, they will dismantle the solar. All right, next. Can you share what are the main source of failure for solar panel or PV farm?
At the moment, the weakest link that we see is really the inverter. I have been working with inverter for most of my professional life. Actually, when I did my PhD more than 20 years ago in Southampton, we were looking at injecting from a source, either RE or not. What the project that I was working on, uh, flywheels energy storage, injecting into the grid. So I was specifically looking into the inverter side, how to get the most gain or low loss using a PWM inverter. So it's iterative learning PWM inverter. So my thesis was on that in Southampton back in the year 2000. So from the start of my career until now, I have been looking at inverters, and unfortunately for solar power applications, one of the main source of failure is on inverters, because we are dealing with switching, we are dealing with high frequency of switching. If we are going into PWM switching, and we are going into um, low harmonics inverters. So when we have switching, when we have electronics, then we are dealing with quite, I would say, quite fragile equipment lah. If you compare to transformers, for example, transformers, cables, PV cells, and so on, those are quite hardy. So for inverters, normally we budgeted into the project cost, replacement cost for inverters. If when we look into the cost of solar panels, we look at the lifetime of the solar panel, we can safely say the solar panel can last between 20 to 25 years. But for inverters, we are looking in at about 5 years of life cycle for the inverter. So we have to put into the maintenance budget for the whole of the project duration some replacement cost for the inverters. So every 5 years, there would be some components being replaced for the inverters.
Okay, thank you. Next question. What is the best solution to solve the solar panel intermittent problems from Mr. Ramdan?
I would like to say it's battery. I would like to say the solar panel combined with the battery would give us very good dispatchable solution for renewable energy. But then again, when we look at the battery, then the cost will rise. As soon as you put battery into the equation, the cost will triple, if not quadruple, it will triple. Okay, so for us to have, let's say, 100 megawatt for 4 to 5 hours a day, only solar. And if we want to have 100 megawatt with battery, that will give you 100 megawatt 24 hours a day, then the end tariff that we will end up with will probably triple or quadruple. So when we talk about that kind of tariff, it won't be competitive. It won't be competitive with the unfortunately, with the cheap fossil fuel based generation that we have at the moment. So I would say my best solution would be solar panel plus battery, but I would like to see the price of the battery to come down lower enough for it to be competitive with the fossil fuel generation. Or if we need to encourage renewable energy further, then we need to put in carbon tax for fossil fuel based generation to make it more expensive. Therefore, renewable energy plus battery can compete. So that is another a whole discussion that goes into how do we tax, how do we put carbon tax. Then at the end of the day, everybody will pay electricity, expensive electricity, economy will suffer, people will suffer, and then we are going to have a problem. So that is another set of a whole total set of discussion.
Okay, thank you. Next question. Is it possible for Malaysia to rely on 100% of renewable energy as power source?
Um, if you ask me now, I don't think so. I don't think Malaysia can rely 100% on renewable energy as a power source unless we stop the growth of energy. We stop the growth of energy use, because at the moment we can never catch up with the growth of energy and then the replacement of renewable energy into the energy equation. So we always require that base energy coming from fossil fuel. At the moment, I have not seen a solution to that. I At one time I thought nuclear can play a role in Malaysia to give some buffer before we have to grow fossil fuel again. We have to buffer the energy mix with nuclear. I have nothing against nuclear. At least with nuclear, we know where the waste, the radioactive waste of the nuclear is. We can contain it and we can deal with it. Whereas for fossil fuel, every day we are emitting the carbon into the air. We are emitting the greenhouse gases into the air, and we cannot ever get it back and contain it. It's already out there. Whereas for nuclear, we can contain it. We know where the waste is, and it's not out there. And but of course, every now and then when catastrophic failure happens for nuclear power, then it has gotten a lot of bad publicity. So I think it's very difficult.
All right, thank you. Next question. Yeah, the Ukraine-Russia war has undoubtedly negatively impacted supply chain and is further impacting the supply of material. Do you see a similar trend if there is a similar tragedy happening elsewhere in the world and somewhere close to our region? From Dr. Jason.
Yeah, thank you, Jason. Yeah, definitely. I see. I can see that actually geopolitical happenings around the world is very important, and you can see even as far as Ukraine and Russia is quite remote for us. It's quite remote, but it has impact onto our economy. When economic sanctions comes in, then straight away we are going to be affected. Now, if you coming back to your question, you said what if it happens nearer to us? You know what came to my mind? China. What happened if somehow there would be fallout between Malaysia, US, and China? What's going to happen then? We can, if we, in the context of solar, we can see that PV panels manufacturers are controlled by China. So if we cannot trade with China, the whole world, not only Malaysia, the whole world will be affected. So I think it's very important that we keep this geopolitical conflicts to a minimum for us to be
Mm-hmm.
able to move forward.
Mm. Okay, thank you. From Mr. Abdullahi, what are the major challenges faced by solar energy industry today?
Okay. From my perspective, from the presentation that I have discussed this morning, I think the major challenge faced by solar energy industry today is the fluctuation in price. In terms, from the point of view of a solar power plant developer, because this is one of the biggest risks when we talk with lenders, when we need to get financing for our project. Now, financing is very important for a market developer, for RE developer, because nobody would want to use their own money 100% to develop their power plant, because we simply don't have that capacity, and we don't have that luxury of having our own money and equity 100%. So we need to borrow. So when we talk about borrowing, we need to reduce the risk much, because we need to get the financing at a very competitive and uh, uh, attractive rates. So one of the things that is quite damaging for us is this fluctuation of PV cells prices. It's very, very important. So I think this is the challenge that we are facing today. But maybe after 2022, that problem will go down and relax, and it won't be that significant.
Mhm. Okay, so this is last two question. Yeah, why
Okay.
there is a differences between LSS3 and LSS4 in term of the tariff?
Okay. When Suruhanjaya Tenaga set the reference tariff for LSS3 and SS4, they were looking at the market price of PV panels, because PV panels make up about 60% of the project cost. Okay, so at that time, during the floating of the LSS3 tender, the panel price was high high enough that when we calculated the tariff, it would go to 32.4 cent per kilowatt hour. Yeah. So at the for the past 10-15 years, safely 10 years to 15 years, the price of the solar panel has reduced a lot. If you remember, when the time when it was a time when Malaysia was doing the feed-in tariff for solar panel, the tariff was even as high as RM1.20 per kilowatt hour, 100 RM1.24. Those above RM1. So now it has become much less than that. Why? Because the solar panel price has reduced. So between LSS3 and LS4, it was just a couple of years, and the price has gone down a lot, such that the tariff goes down further to from 32 to 24 cent per kilowatt hour. Yeah. So even now, because of the blip, then we are seeing that the solar panel price has increased. But when the blip comes down, it should be lower again.
Mhm. Thank you. Okay,
Besides
this is the
solar,
last question. About any plan in Malaysia to use like wind or wave energy?
do you have any plan to use any resources, e.g., wave, wind, etc.? You means us, me, or Malaysia? Okay, let
Mm.
me let me talk about me as representing my company, lah. Yeah, we always look at different RE sources. We look at wind. We also look at geothermal. If you remember, at the start of my presentation, we have two power plants in Sabah, so we are quite strong in Sabah. And because Sabah is near to where the ring of fire is, the 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 failure between the plates that goes down, the ring of fire that goes down from Philippines to Indonesia, where they have a lot of volcanoes. So that ring of fire goes a little bit into Sabah. So that means in Sabah we had volcanoes. We had volcanoes in Sabah many million years ago. So that's why we have the Mount Kinabalu and all those mountain range in Borneo. That was because of the plates, the failure between the plates. So it also means that we have geothermal resource in Sabah. So we look into geothermal, and we also look into biomass. We also look into wind, but wind is not that much. We know where the resource for wind is strongest in Malaysia is in Sabah as well, near Kudat. So we look at Kudat, we look at Tawau for geothermal and wind. So, but as always, the cost of the technology is quite high. So that is the challenge that we have now.
Okay, thank you very much, Dr. Zahrul. Actually, there are a lot of questions, but due to the time constraint, we need to end the session. And we are really, I believe that everyone agree that we are really enjoying this discussion. A lot of insightful information from your side. We really appreciate that.
Thank you, Prof.
Okay.
I hope I didn't have too long the gap just now, because I didn't realize that I was disconnected from the internet until one of the committee called me.
Yeah, that's the challenge lah in this online. Sometimes we not realize we keep talking, but suddenly nobody in front of us. All right,
Yeah.
it's okay, Dr. Zero. We managed to catch up that. Okay, so just a token of appreciation. This is the e-memento. Unfortunately, due to virtual, so we give a virtual e-memento. Inshallah, if you come over to Peninsula, we can meet and we can hand over this memento to you. Yeah. So thank you very much for your participant and all the participant of today. Okay, and special thank to Dr. Zahrul Faizi for joining us today. Thank you very much. Okay, have a nice day,
Thank you
everyone.
very much.
Assalamualaikum.
You too. Waalaikumsalam.
University Technology Mara, or UITM, has been the place for acquiring knowledge and developing capabilities. From a training center to now a vast network of universities, UITM has campuses and faculties all over Malaysia. UITM allows for the pursuing of goals and earning a degree in any field of choice, with a mission to enhance the knowledge and expertise of Bumiputras in all fields of study, through professional programs, research work and community service, while upholding moral values and professional ethics. Nestled amidst the greenery and some of the most scenic areas in the country, each university campus is strategically located in places where their presence inevitably provides an economic boost to the local community. The Vice-Chancellor is the Chief Executive Officer, heading the academic and administrative management of the university. UITM pledges to provide maximum opportunities to pursue professionally recognized programs of study in science, technology, industry, business, arts and humanities. University Technology Mara offers quality education at all levels of study, from foundation to postgraduate. The university has always been at the forefront in science and technology, as well as in management. It is a place where talent, skills and excellence are nurtured. UITM has a mission to empower the indigenous people through the provision of higher education in accordance with Article 153 of the Malaysian Federal Constitution and Act 173, University Technology Mara Act 1976. Duli Yang Maha Mulia, Sri Paduka Baginda Yang di-Pertuan Agong is the Chancellor of UITM by virtue of his status as the King, as provided for by the law. To complete the teaching and learning activities at UITM, the university has made available modern and contemporary facilities such as the UITM Stadium, the house of UITM FC. With a capacity of 6,000, the stadium is the heart of soccer and it has played host to an international match in 2009. UITM also has an Olympic-sized swimming pool for the use of students and staff. The pool is also open to public on certain days. Built in 1972, Perpustakaan Tun Abdul Razak, or the PITA Library, has grown by leaps and bounds, housing thousands of international titles for all programs of study. Students' participation in extracurricular activities is highly encouraged and supported by the university. These activities would not only equip students with soft skills, but also train them to be balanced and holistic individuals to meet global requirements. As the largest public university in Malaysia, University Technology Mara has produced thousands of alumni who are successful individuals in their disciplines. University Technology Mara, Usaha Takwa Mulia.